Alright, good morning. Today we're looking at Unit 6, Section 1. This is the first handout from this section. I'm going to title it A over here. So you see that? And we're going to look at Pythagorean theorem word problems. So first thing I want to do is draw a picture of the situation, and then we will find the missing side. So look at number 1. The bottom of the ladder must be placed 3 feet from a wall. The ladder is 10 feet long. How far above the ground does the ladder touch the wall? So we have this ground level. The bottom level is 3 feet from the wall. So if this is our wall, the ladder is 3 feet from the wall. So here's the bottom of the ladder, and then the ladder is going to go up this way. Okay, so here's our ladder. Okay, the ladder is 10 feet long, so there's 10 feet on the ladder. And we want to know how far above the ground does it touch. So I'm going to try to find that side right there. So using Pythagorean theorem, we have a squared plus b squared is equal to c squared. I know a down here. I don't know b, and Pythagorean theorem always says my hypotenuse is always going to be c. So let's fill in the blanks here. 3 squared plus b squared is equal to 10 squared. Okay. So if I do a little math here, 3 squared is 9, 10 squared is 100. I'm going to take away 9 from both sides when I'm done. So I get b squared is equal to 100 minus 9 is 91. And then, of course, the last step always of Pythagorean theorem is square root my final answer. So on my calculator then, I'm just going to go square root of 91, and I get about 9.53 or 9.54 feet. So there's my final answer there. Again, 9.54, about 9.5 feet. Okay. Number 2, I'll set the problem up for you, but I'm not going to do it. I'm just going to go through do the odd ones. The soccer field is a rectangle, so let's draw a rectangle. 100 meters wide, so let's go 100, and 130 meters long. I know the picture doesn't look like it, but just go with those numbers. It's okay. The coach asked players to run from one corner to the other. So if they start here at this corner and run to the other corner, how far did they run? And that looks like it's going to be my hypotenuse, because the soccer field has right angles on the corners. So I'm going to call that C. So we're going to go 100 squared plus 130 squared is equal to C squared. So there's the setup, and I'll let you finish it off. Remember, make sure you are square rooting your final result to get it down to C. So make sure you do that. Alright, number 3. How far from base of the house do you need to place a 15-foot long? It's another ladder question. So that it reaches the top of a 12-foot tall wall. So this is my wall. We know it is 12 foot tall. The ladder, for safety measures, has to be away from the wall. So how far from the base of the house do you need to place the ladder? So this is the base down here. So we'll just call that B for base. And this will be my ladder then. So bear with me on the pictures. So there's the ladder, and it's a 15-foot long ladder. So 15 has to be my hypotenuse. 12 in this case, we'll let it be the letter A in my Pythagorean theorem. So again, a squared plus b squared is equal to c squared. So we have 12 squared plus what I don't know squared is equal to 15 squared. So 12 squared, 12 times 12 is 144. Don't know b squared, but I do know 15 squared. It's 225. I'm going to subtract 144 from both sides. Okay. And then I believe I get b squared to be 81. Then square root that. Square root of 81 is equal to 9 feet. So that is what my base would have to be, 9 feet. Alright, number 4, real simple here. What is the length of diagonal of another rectangle? So again, drawing the picture, a rectangle. Let's go 15 on the bottom, 10 on the side there, right angles are down here in the corners all the way through. When you're trying to find your diagonal, we'll call it C. So setup for that one, 10 squared plus 15 squared is equal to C squared. So this is going to be pretty easy. 110 squared is 100 plus 225. That gives you 325. Again, that equals C squared, and then make sure you square root your final answer. So I'll let you figure that out on your own. Okay? Alright, so flipping the worksheet over, we now have questions 5 through 9. Alright, looking at number 5, this is another rectangle problem. What is the length? Okay, this time the diagonal is 25, so label your diagonal 25. The width is 15. And what is the length? So you're trying to find, let's call this A. So we're trying to find that distance right there. Okay. So the setup for this one, again, A squared plus B squared is equal to C squared. Okay, double check here. We'll let A squared we don't know plus 15 squared is equal to 25 squared. So there is the setup, and I'll let you go through and finish that one off. Alright, two sides of a right triangle are 8 and 12. Find the hypotenuse. Oh, that's easy to do. So let's make sure we're drawing a right triangle. There's my right angle down there. Find the hypotenuse. We'll call it C, because that is the Pythagorean theorem. 8 on the bottom, 12 along the side. And it really doesn't matter which one is 8, which one is 12. So they're looking at 12 squared plus 8 squared is equal to C squared. Again, I'll let you finish that one up and get your final answer there. Again, make sure you're square rooting your final answer. A baseball diamond is a square. So let's draw a square. Kind of tilted just a little bit. 90 feet on every side. Oops, make it 90. So 90 all the way around. What is the distance a catcher has to throw the ball from home plate to second base? So home plate is down at the bottom, and we're trying to throw it this way. So you're calculating another diagonal. And then, since it's a square, we have right angles at every corner, kind of like the bases are. So 90 squared plus another 90 squared is equal to my hypotenuse squared. So there is the setup. I'll let you guys finish this one off. Okay. So what does C give you at the very bottom? Number 8. Okay, Dad leaves the house to go to school, or David does. He walks 200 meters west. So if I just put a dot on my paper, draw a line west, going in this direction, there's 200, and then 125 meters north. So it goes this direction. So my right angle then is right there in the corner, and I'll label this 125. We're measuring in meters. How far away is he from the starting point? So it looks like we're trying to find this distance, because remember, he started here at this corner and went this direction, then went up. So this is going to be my hypotenuse, so I'm going to call it C. So we'll set this one up. Again, I will let you finish it off. It's important you have the setup, so then you can get it down. So you, again, finish the work, get that done. And lastly, number 9. A park is the shape of a rectangle. So I'll draw a rectangle. 8 miles long, so let's throw 8 on the bottom. 6 miles wide, we'll go 6 on the side there. How much shorter is your walk if you walk diagonally across the park than along the two sides? So I do have to calculate my diagonal. Okay. Call that C again, since it is the hypotenuse of my Pythagorean theorem. So 8 squared plus 6 squared is equal to C squared. This one we're going to do all the way out. Okay, 8 squared is 64, plus another 36 equals C squared. Add these together and you get 100 equals C squared, and then I'm going to square root that. So square root of 100 is 10. Now, is that my final answer? Let's double check. No, it's not. How much shorter is your walk if you walk diagonally. So if I walk diagonally, I'm going 10 miles. Okay, all the way diagonal. Now how long is it if I walk the sides of it? 8 to 6. Well, 8 plus 6 is equal to 14. Well, how much shorter is it? What's 14 minus 10? That gives me 4 miles shorter. If I just use my diagonal, 4 miles shorter. So again, notice it wasn't just not only finding the diagonal, but I had to find how short it was going around my figure halfway, going 8 and then 6. Add those up and then take it away from the diagonal length, which is 10, and final answer 4 miles shorter. Alright, you guys finish the rest of them up and we'll work on the next handout.